Hi everyone, my name is Sam Go, and I am joined by my brother Josh Go, and we will be going over Algebra I review today. In this module, we will be covering 40 sample questions that we picked from previous Regents, and the types of questions that we chose are according to the breakdown provided by the Regents board. The breakdown is as follows. For number and quantity type of questions, we have 5% or 2 questions. For algebra questions, that's 50% or 20 questions. For functions, we have 35% or 14 questions, and stats and probability, which is 10% or 4 questions. So without further ado, let's begin. All right, so in this problem, this is a numbers and quantity type of question. A news report suggested that an adult should drink a minimum of 4 pints of water every day. Based on this report, determine the minimum amount of water an adult should drink in fluid ounces per week. So there's 2 things we got to keep in mind here. We're changing pints to ounces, and we have to change day to week. So let's keep those in mind. So you will find most of these conversions in the reference sheet that's provided in your Regents booklet. And the most important thing here is to find these conversions, right? So we need to convert 4 pints into ounces. Right? How do we get that to ounces? So what you'll have to do is find in your reference sheet that 2 cups is 1 pint. Okay. And in addition, 1 cup is 8 fluid ounces. So given this, it'll be pretty easy now to go from pints to ounces. So we'll do that first, then we'll deal with the per week after we do this. So we'll go from pints to ounces. So we have 4 pints, okay? Let's multiply it to try to get it to cups. So we have 2 cups in a pint, in 1 pint, okay? So these will go away, so that's 8 cups. It's a nice little streamlined way of doing it. And then we now have to convert cups to ounces. So we can write the same type of thing here, 8 fluid ounces to 1 cup, right? So the cup and the cup go away. So we're left with 4 times 2 times 8 fluid ounces. So that's 64 fluid ounces in 1 day, right? Because we just converted the 4 pints in 1 day. So that's 64 fluid ounces. To go to a week, we need to multiply that number by 7, right? Because 1 week is 7 days. And so that's 64 times 7. That'll give us 448 fluid ounces as our final answer. So in question 2, we're given these 4 numbers. L equals root 2, M is 3 root 3, N is root 16, P is root 9. And it's asking us which expression results in a rational number. So just to review quickly what the differences are, a rational number can typically be written as a quotient or as a fraction. So 5 over, there's some examples here, like 5 over 7, 1 over 2, 3 over 3, etc. An irrational number, on the other hand, cannot be written like that. So they're the stranger numbers. So as an example, root 2 here is an irrational number. So there's some examples. Root 2, pi, you guys are probably familiar with pi, among other numbers here, etc. So we want a rational number. So there's a couple rules we have to just remember here. 1, if you add 2 rational numbers, like 5 plus 5, or some of these fractions together, 5 sevenths plus 1/2, you will always get a rational number back. 2, if you do an irrational number plus a rational number, or via the commutative property, you can also say rational number plus irrational number, you will get an irrational number. And it's because of that addition of this guy here, these 2 rationals, right, that will make the answer irrational. And likewise, when you have an irrational plus irrational, you will get an irrational number. So to get a rational number, because that's what the question is asking for, we want to add 2 rational numbers. We can very quickly just go through each one of these and see which one's rational and which one's irrational. So we know we could do these really quickly, because we don't really have to look at this, because we know the square root of 16 is 4. we know that the square root of 9 is 3, and we know those are rational numbers. 4 you could write as 4 over 1, and 3 is 3 over 1. So I don't really have to look at the rest of these up here. I could just go ahead and pick n plus p, and that will be answer 3. In this next question, we're now in the algebra section. Next 20 questions here. And in this one, we're going to look at inequalities. So we have two inequalities that are given. I like to write them in the standard y equals mx plus b type of form. So why don't we just do that real quick? So the first one should be y is greater than negative x plus 2. All I did was subtract x from both sides. And this one we can leave as is. Y is less than or equal to 3x minus 2. So after looking at these, we can just graph them as if they were lines. I can immediately eliminate two answers. That's 1 and 3. The reason is we have a greater than sign here, not greater than equal to. So we need one of the lines to be a dotted line. These both have solid lines, and that's not correct. So we're between 2 and 4. So that narrows our choices down pretty quickly. So now we have to just make sure the shading direction is in the correct direction. So we can do, let's do this one first. Let's do the bottom one. Might be clearer to see. So this line right here, 3x minus 2, I know is this one, this line that I'm highlighting in red, because the intercept is at negative 2, and that's over here. And also it's a solid line because it has the less than equal to. So that's a solid line. And it's saying y is less than or equal to 3x minus 2. So the idea is which direction should we be shading in? So let's plug in 0, 0. Right? Just as a point, see if that fits the inequality. So try this, plug 0, 0. So we have, again, I'm just going to rewrite here. Okay, 0, is it less than or equal to 3 times 0 minus 2? This goes to 0. Is 0 less than negative 2? This is false. So that means we are not going to be shading toward 0, 0, which is over here. We're not going to be doing that. Let me use a different color. Here's 0, 0. This would be the wrong way to shade. We have to shade downward. And so, just by process of elimination, we know that the final answer should be choice 2, as it shades downward. In question 4, the question states, the third term in an arithmetic sequence is 10. The third term is 10. And the fifth term is 26. If the first term is a1, which is an equation for the nth term of the sequence? Now, if you go to your reference sheet, they give you a formula that looks something like this. an, which is the nth term of the sequence, is equal to a1, the first term, plus some n minus 1 d, some constants. Now, you could solve it with this, but it's not really necessary. We can simply plug in to the multiple choice answers. That's 1, 2, 3, 4, and 5. These are the terms of the sequence, and they tell us this is 10 and this is 26. Now, this means n equals 3 should give us 10 for the sequence, for the number in that sequence. So we could just start plugging in and see if that works. So let's plug into choice 1. So a3, the third term in the sequence, should be 10. And it's equal to 8 times n, which is 3, the third term, plus 10. That gives us 24 plus 10 is 34. That is not equal to 10. Not equal. So we don't like that. Let's do choice 2. Let's cross this out here. Choice 2. We're getting the third term should be 8 times 3 minus 14. Well, if we look at that, 24 minus 14 gives us 10. So that checks out. To be certain, we should check this number as well. So I'm going to plug in 5, the fifth term of the sequence. Should be 8 times 5 minus 14. It's 40 minus 14 is 26, and that checks out as well. So our answer, we can confidently say, is choice 2. Here's question 5. Fred is given a rectangular piece of paper. If the length of Fred's piece of paper is represented by 2x minus 6, and the width is represented by 3x minus 5, then the paper has a total area represented by. Well, we know that the area of a rectangle rectangle is equal to its length times its width, right? And that's, if we drew a quick picture just to see what that looks like. Here's a rectangle, here's the width, here's the length. You multiply the two, you can get the entire area here. So this is pretty straightforward. The dimensions aren't given explicitly, but they're given as expressions, and that's not a problem. So the length, it says, is represented by 2x minus 6, and the width is represented by 3x minus 5. Length times width. So let's do that real quick. Length times width. Length times width. So we have 2x minus 6 times, and I'll color code this so we can keep track of all our different dimensions. And now we just simply have to FOIL. That's the first 6x squared outside, minus 10x. Inside, it's minus 18x. And last, which is plus 30. And when we combine everything together, these two can be combined. That's 6x squared minus 28x plus 30. That should match up with choice number 2. In this next question, we are asked if the difference 3x squared minus 2x plus 5 minus the quantity x squared plus 3x minus 2 is multiplied by 1/2 x squared, what is the result written in standard form? Just to remind ourselves what standard form is, it's nothing fancy. It just reminds us that standard form is writing the final answer, so written in decreasing polynomial order. Decreasing polynomial order. And that basically means, just as an example, you want your x to the 4th first, plus x to the 3rd, plus x to the 2nd, plus x, and plus some constants. You need to have your higher numbers first, and then in decreasing order, as you can see here. So with that in mind, let's take the difference first. We'll worry about multiplying by the 1/2 x squared after. So we have 3x squared minus 2x plus 5. Let's distribute all of these in. So we have minus x squared, we'll have minus 3x, but we'll have plus 2, because that's a negative times a negative. All we have to do is just line them up and combine like terms here. So we'll have 2x squared minus 5x plus 7. So that's our difference. That's good. Step 2, let's multiply it by the 1/2 x squared. So multiply by 1/2 x squared. 1/2 x squared multiplied by 2x squared minus 5x plus 7. All we have to do is really just distribute the terms. And remember that exponents add if they're the same base. And so we'll have 1/2 x squared times 2x squared. That's the first term. I'm going to do each term here. So 1/2 x squared times 5x plus 7 times 1/2 x squared. Okay, so that's just distributing. If we combine everything together now, let's see, we have half times 2 is 1. Let's just give us x to the 4th. This one's done. This one is negative, I'm seeing 5 halves x cubed, because that's 2 plus 1, plus 7 halves x squared. That should be our final answer. So here we're given 4 expressions below, and we see them as choice 1, 2, 3, and 4. And we want to know the expression 4x squared minus 4x minus 120 is equivalent to which one of these 4. So really the only way to do it is to see if the terms all line up, the x squareds, the x's, and then this constant term over here. We need to see if they all line up. So why don't we go from the top and just work our way down. So 2 times 2, if we just kind of distribute these in, 2 times 2x squared is 4x squared. That looks good so far. Minus 4x. That looks good so far. And then minus 120. That looks great. So 1 is going to be in our answer, already eliminating 2 and 4, because they don't have 1 in them. You can eliminate those. Let's do the next one. Distribute that 4. We have 4x squared minus 4 And 4 times negative 30 is negative 120. Sorry, 4x here. Negative 120. That checks out. So 2 can be an answer. That doesn't eliminate more answers. We have to see if 3 or 4 could be answers as well. So this one has 4 in it. So might as well check number 4 here to see if that is the answer. So we can go 4x times x is 4x squared. 4x times negative 1 is negative 4x. And then there's this minus 120 at the end. So that checks out. We can be confident that our answer is choice 3. This next question asks, given that a is greater than b, and that's an important point, solve for x in terms of a and b. This is a pretty straightforward question, so let's just start distributing and combining like terms. So I'm just distributing this in here as bx minus 3b is greater than or equal to ax plus 7b. Pretty straightforward so far. Let's combine like terms. I'm going to bring my b's to this side and my x's to this side. So all I'm really doing is subtracting from both sides, subtracting and adding. So let me be a little more thorough. So I'm going to say plus 3b minus ax. Do that to both sides, right? So we get bx minus ax is greater than or equal to 10b. So I'm going to factor out the x here. So b minus a times x is less than or equal to 10b. Now we have to bring back this part I circled in green from before, that a is greater than b. So if we look at this expression b minus a here, if a is greater than b, then b minus a must be negative. And we can convince ourselves, we could plug in really any number. We could say if b is equal to 3 and a is bigger than b, let's say a is equal to 4, well then 3 minus 4, b minus a, is negative 1. It's going to be negative. And so what happens when we are trying to solve for x, we have to divide both sides by b minus a. So x is less than or equal to 10b over b minus a. However, the rules in inequalities is when we divide or multiply by a negative number, and that's that b minus a, you have to flip this sign. So our final answer should be x is less than or equal to 10b over b minus a. In this next question, we are being asked, Sue and Kathy were doing their algebra homework. They were asked to write the equation of a line that passes through negative 3, 4, and 6, 1. Let's just quickly draw that so we know kind of what we're looking at. It's an equation of a line. Here's 6. Let's say here's 1. So we're about here. 2, 3, 4. Negative 1, 2, and 3 puts it about here. Okay. So we could draw a line through that. There we go. And I'll label the points 6, 1, negative 3, 4. Sue wrote this one equation here, and Kathy wrote this equation. The question is asking us to justify why both students are correct. It's interesting because they don't look quite the same right now. So, option 1, which I won't go very heavily through here, but option 1 is to plug in the ordered pairs. Plug in ordered pairs. And what I mean by that is you're given these 2 points, point 1 and point 2 we can call them, and if you plug them into Sue's equation as the x and y values, and Kathy's equation as the x and y values, it will result in an equation that holds true. I'm more interested here in showing you guys how to do it with the point slope method. Point slope. And that's an equation of a line given a point and given the slope. So we should first find the slope given those 2 points, 1 and 2 that we have. So that's delta y over delta x, or rise over run, which is y2 minus y1 over x2 minus x1. y2 here is 1 minus y1 is 4 over x2 is 6 minus x1 is negative 3. So that's a 2 plus signs there to negate those 2 negatives. And so we get that the slope, or as we might be familiar with it, m, right? Y equals mx plus b. The slope m is equal to -3/9. In other words, we can simplify to -1/3. Now, we can simply use one of the points. I'll use point 1 in our point slope form. This is what point slope form looks like. It's y minus y1 equals m times x minus x1, where y1 and x1 are just any of the ordered pairs that we have. It could be the second pair as well. So I'm going to start plugging in y minus, and I'm going to choose this y here, 4, equals m, this is m, -1/3, x minus x1 is -3, so that's +3. This is an equation of the line. That is a perfect representation of this line that we've drawn here. Interestingly enough, that's exactly what Sue wrote, so we can verify now that she is definitely correct. To verify what Kathy did, it looks as if she just isolated the y on one side. So why don't we do the same thing? Y equals -3x plus 3 plus 4, just adding the 4 to both sides. And when we distribute this, we'll find -1/3 x plus -1/3 distributed into 3 is -1 plus 4. I'm going to write over here to the left now. When we simplify that, we get y equals -1/3 x. And then we have, 1/3 x, and we have -1 plus 4 is +3. And that is exactly Kathy's answer. And from those two, we're confident that both of them did the question correctly. All right, question 10. The function f of x equals 3x squared plus 12x plus 11 can be written in vertex form as. So vertex form is what you are seeing over here. It's some f of x equals, some x plus or minus some number squared plus some constant, okay? We'll call this c here. We're trying to figure out what these two constants are, okay? So the way you find a vertex of a parabola, this here is a parabola, x squared, right? The way you find a vertex, we'll call it h, okay? It's -b over 2a. And just to be thorough, that's a, that's b, and that's c. Those are the coefficients. So if we solve this out, -12 over 2 times 3 is 6, is -2. That is the x variable, or the x coordinate of our vertex. So what's interesting is this will actually go into here. So we'll keep that in mind. That's going to be some sort of x plus 2, which means we're pretty much already down to choices 3 and 4. Right, because that has the x plus 2 in the parentheses. The question is, how do we find that plus d? How do we find that extra coefficient that comes at the end? And all you actually have to do is plug it back in. Just plug back in the vertex, so plug that -2 back into f of x. So what we're going to do is f of -2 equals 3 times -2 squared plus 12 times -2 plus 11. When we solve this out, we get 3 times 4 plus -24 plus 11. When you solve that out, you will get -1 as that coefficient d. So the final answer should be f of x equals 3 times x plus 2 squared minus 1, right? Because that 3 is from our coefficient 3 there. That gives us our final answer, choice 3.
So in question 11, we have a car that leaves Albany, New York, and travels west towards Buffalo, New York. I'm going to represent here with point A for Albany and point B for Buffalo. And we have a car that's traveling to Buffalo, towards Buffalo. And the equation d equals 280 minus 59t can be used to represent the distance d from Buffalo after t hours. So that's this distance here, from the car to Buffalo. D equals 280 minus 59t. So the question asks us, what does this 59 represent here? It looks like it's the slope of the equation, right? So just by inspection, we can intuitively see that the d represents some unit of distance. Let's call it miles here. It could be inches, it could be feet, but for this purpose, let's just call it miles. The question doesn't specify what it is, so miles. So because the left-hand side is in miles, we know that the right-hand side must also be in miles, right? Miles. Now 280 is just a constant, so let's take a closer look at this 59t term, which is what we want to find. T, the question says, is in hours. So what must 59 be to make 59t equal a unit of mile? So then let's put hours here, multiply that by what to make it equal miles. So to make the hours cancel out, we have to put hours on the bottom, right? And to have miles in the result, let's put miles up top. And we can verify that this does indeed cancel out and give us miles. So we now know that 59 has to be in the units of miles per hour. Now, what does this look like? This looks like a speed of a car. And that's why that's the answer. To make sure that this is the right answer, we can also, as a second option, look at the other three answers. So answer choice 3 says the distance between Buffalo and Albany. We know that at t equals 0, d equals 280, right? At t equals 0, which represents the car still being at Albany, and it still has to travel the entire distance, meaning 280 is the distance between Buffalo and Albany. Now this isn't 59. And let's label that here over on this diagram, so we know that this entire length is 280. So answer choice 1 is car's distance from Albany, which is this distance over here. So to get that, we can simply take the entire distance and subtract d from it, right? But that definitely isn't 59. And finally, we have the number of hours driving, which is when d equals 0, right? When the distance between the car and Buffalo is 0. So it's the time at which the distance equals 0, which is definitely not 59. That's 0 equals 280 minus 59t. Negative 280 equals negative 59t. And by dividing 59 on both sides, we're sure that this isn't 59. Therefore, it's not the number of hours of driving as well, which leaves us with the speed of the car. So in this question, we have, in attempting to solve the system of equations y equals 3x minus 2 and 6x minus 2y equals 4, John graphed the two equations on his graphing calculator. Because he only saw one line, John wrote that the answer to the system is the empty set. Is he correct? Explain your answer. So let's take a closer look at both of these equations. I want to convert this second equation quickly to a y equals mx plus b form so I can visualize it. So 6x minus 2y equals 4. So let's bring the 6x over to this side. So it becomes negative 2y equals 4 minus 6x. Divide both sides by negative 2. 4 divided by negative 2 is negative 2. And then negative 6 divided by negative 2 is positive 3. So this equation is simplified to y equals 3x minus 2. And we can see, wow, it's the same as the first equation. So this means that because John only saw one line, it's not because the solution is the empty set. Rather, it's that both lines are on top of each other. So let me draw this out quickly. We have the first equation, let's just say, goes this way, and this is the y-intercept at negative 2 with a slope of 3. And the second line would be right on top of it. Bam. So this means that the solution is not the empty set. Rather, it's all points on the line. Because they're the same line. So in this question, it asks, Central High School had 5 members on their swim team in 2010. Over the next several years, the team increased by an average of 10 members per year. The same school had 35 members in their chorus in 2010, and the chorus saw an increase of 5 members per year. And then we're asked to write a system of equations to model the situation, where x represents the number of years since 2010. So let's start off with the swim team, I guess. And we want to try to make the equations, just for simplicity's sake, y equals mx plus b. So we know that for the swim team, we have 5 initial members, and then it grows at 10 members per year. So we know that 5 members would be our initial value, which is b, and then 10 members per year would be our slope. So 10x equals y, I'll write y in subscript s, ys. So similarly, we can do the same thing for chorus. Let's do yc for chorus equals, it said that the initial value would be 35 members in 2010, so that's plus 35 at the end, and then the chorus saw an increase of 5 members per year. That would be our slope, and that's it. So this question asks, a construction worker needs to move 120 cubic feet of dirt using a wheelbarrow. One wheelbarrow holds 8 cubic feet of dirt, and each load takes him 10 minutes to complete. One correct way to figure out the number of hours he would need to complete the job is... So here I suggest, with these convergent factor questions, just let's look at each of these answer choices and look at what types of unit it produces, what types of units. We know that the final answer should be in hours, so that's what we're looking for. We're looking for hours. So in this first answer choice, we can see that cubic feet cancels with cubic feet, load cancels out with load. So at the end, we're left with minute times minutes over hour. And that's definitely not hours. So let's cross this out. In answer choice 2, you have minutes canceling with minutes, and I think that's it. So you have cubic feet times cubic feet over hour loads, which doesn't make sense. Similarly, in number 3, we have load canceling with load, and I think that's it. And that would leave us with the units of this cubic feet times cubic feet times hour over minute times minutes. That's definitely not hours. So finally, with answer choice 4, you have this, you get to cancel out so many things. Cubic feet and cubic feet here, load and load here, and finally minute and minute here, leaving us with hours as our solution units, which is why 4 is the right answer. Now, in these questions, you're really looking for these terms that cancel out, feet cubed and feet cubed here, load and load, these diagonal cancel out terms. And that's how you solve that. But I also wanted to look at, if you guys wanted to actually work this out brute force, we know that this construction worker has to move 120 cubic feet of dirt. And then we know that each wheelbarrow he wheels in each of these for each of these loads can only hold 8 cubic feet. So we know that to calculate how many wheelbarrow loads he needs, we can divide this by 8 cubic feet, and I think that's 15 loads on his wheelbarrow. So we know that each load takes him 10 minutes to complete. We can just multiply each load by 10 minutes. And that would give us 150 minutes. And simply, we can convert this easily to hours by dividing it by 60. 150 divided by 60 equals, I think that's 2.5 hours. And then you can try and just put each one of these answer choices into your calculator to see which one yields you 2.5 hours. So that's the second option. So this question asks, using the formula for the volume of a cone, express R in terms of V, H, and pi. So looking at your reference sheet, this one you actually have to refer to your reference sheet, unless you already know previously the formula for a volume of a cone. But the volume is 1/3 pi r squared h. That's the volume of a cone. So all this question is asking us to do is rearrange all these terms so that it becomes a r equals something, right? So let's reorganize it. So we want to try to isolate this r over here. Let me change the color. So let's multiply 3 on both sides. So it's going to become 3v equals, and that cancels out the 1/3 pi r squared h. Now let's divide both sides by pi h. And that becomes 3v over pi h equals r squared. Now we can simply take the square root of both sides, and that isolates r for us, right? So r equals square root of 3v over pi h, and that's our final answer. So for question 16, we have Alicia purchased H half gallons of ice cream for $3.50 each and P packages of ice cream for $2.50 each. Let's quickly write that down on the side. So we have the ice cream that costs $3.50. And then we have the cones that cost $2.50 each. So it says that she purchased these 14 of these items and then spent a total of $43. And now, which system of equations could be used to determine how many of each item Alicia purchased? So we know that if she purchased H half gallons of ice cream and P packages of ice cream, H plus P would total to 14 items. So that allows us to eliminate answer choices 3 and 4 immediately. So now let's look at this, the price, the total amount of money she spent. So because she purchased H half gallons of ice cream for $3.50 each, we can do 350 multiplied by H. And that would give us the total amount of money she spent on half gallons of ice cream. And in the same way, we can do the same exact thing for the number of ice cream cones. P packages of ice cream cones, each costing $2.50. So that's 250 times P. And that will give us the total price, total amount of money she spent on ice cream cones. And if we add that together, we get the total amount of money she spent, which is 43. So we can see here that answer choice 1 reflects this. So this question gives us a quadratic equation, x squared minus 6x equals 12, and it is rewritten in the form of x plus p squared equals q, where q is a constant, and it's asking us to find the value of p, which is here. So looking at it, we can see that it's very similar, in fact, to the vertex form. Now, just as a reminder, vertex form looks like this, where h and k are the vertex of the quadratic. Let's just do a random quadratic, and that would be this point over here. So to calculate h, it's defined as negative b over 2a. So let's try to find the coefficients from the original quadratic right here. So this first term is a 1 here, right? So that would be our a. This negative 6, pay attention to the signs, that would be our b. And then c would be, if this 12 was still put onto the side, so that would be c equals negative 12. all we need is b and a. So we know that b is -6, -6, and a is 1. And that gives us 3, which we would plug in into here. So x minus 3 squared plus k. So this question doesn't ask us what this k value is, and it's also put on the opposite side. But all we're concerned with right now is this term over here. So we know that to make this x plus p squared equal to x minus 3 squared, p has to equal -3. So question 18 asks us to solve the following equation by completing the square. And this is the equation, x squared plus 4x equals 2. So to complete the square, it gets turned into some sort of form where you add something on this side, and because we add something on this side, we also add something on this side, right? So I just want to note here that if this equation was put into another form, x, where the 2 is on the opposite side, plus 4x minus 2, let's say it's in this form, right? That what you would be doing is trying to get it into this type of form, x squared plus 4x, where you add something on this side, right? But because you add something on this side, you still have to keep this equation balanced. And to do that, you would also have to subtract the same number from this, because it's on the same side. You have to subtract that same number. I just like to make that note. So what would this number be? This number would be b over 2 squared. So in this case, this 1 here would be a, this 4 would be b, and then c would be, if it would be -2 because this 2 would be put on this side. But all we need is b, so b is 4, so 4 over 2 squared equals, this term turns out to be 2, and 2 squared would be 4. So we know that the value that we're adding on both sides is 4. So let's see what we can do with that. X squared plus 4x plus 4 equals 2x plus 4. Nope, equals 2 plus 4. 2 plus 4. So we know that this is 6. And then we can put this into, because now that we've completed the square, we can do x plus 2 squared, right? If we were to FOIL this out, x plus 2 times x plus 2, we'd get x squared plus 4x plus 4. So now because we got this, we can try to solve for x now. So we can take a square root of both sides. Let me rewrite everything here, just so all the steps are clear. X squared equals 6. So I'll take a square root of both sides. I'll change my color to blue. Let's take a square root of both sides to cancel out that squared value. You get x plus 2 equals plus or minus radical 6. And then we can subtract 2 from both sides and get x equals plus or minus square root of 6 minus 2 as our final answer. Just remember, when you're taking the square root, it could mean that it's positive or negative. So this question asks, if c equals 2a squared minus 5 and d equals 3 minus a, then c minus 2d equals. So this question is pretty simple. We can just take this c value, plug it into here, and then the d value, we can plug it into there, right? So let's pay attention that it's 2d rather than d, and c equals 2a squared minus 5 minus 2d, 3 minus a. So let's distribute this out, right? And we get 2a squared minus 5 minus 6, and then negative times negative is a positive, so plus 2a. So let's combine our like terms. So, and we get 2a squared and rearrange, plus 2a minus 11. And that will be our final answer, which is answer choice 3. So in question 20, it asks, students were asked to write 6x to the 5th plus 8x minus 3x cubed plus 7x to the 7th in standard form. Shown below are 4 student responses. So we have Anne, Bob, Carrie, and Dylan, and it asks us which student is correct. So let's really redefine what standard form is, where you put the each one of these terms in decreasing degrees, right? So you start off with the highest, which would be 7x to the 7th, plus next one up would be 6x to the 5th, plus this one would be minus 3x cubed plus 8x. And now it's all in order, and this would be our standard form. So which student has this as their answer? And it looks like it's Anne. So Anne's our correct answer.
All right, on this next question, we're going to explore inequalities yet again. This time we want to graph the system of inequalities and determine if point 18 is in the solution set. So let's go ahead and graph it first. I'll use different colors here. I'll use red for this graph, and I'll use this light green for the second one. So let's first start by formatting in such a way that we understand a little better. I'm going to do that kind of y equals mx plus b format. So y is less than or equal to negative 2x plus 8, just subtracting 2x from both sides. And I'm going to use my green pen here. And if we do the second one, we'll get y is less than 3x plus 5. Pretty straightforward. And so we can do a little counting here. Let's do the first one with the red pen, 8. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. That's right here. That is the y-intercept. Right, that's where it crosses the axis. And then we go down 2 over 1. That's the slope. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So you'll be provided with a ruler on the exam, but I'm going to try to freehand here. So it's basically a line that goes through right here. It's like that. Got a little squiggly at the end. Then we'll take the green pen, and now we realize it's a less than sign. So this will not be a solid line, but a dotted line. So we'll do the same thing as if we were graphing a line, though. We'll go up 5 for the y-intercept, 1, 2, 3, 4, and 5, right over here. We're going to go up 3 over 1. That's the slope. So up 3, 1, 2, 3, and over 1. That's here. And we can go the opposite way, so over 1 and down 3, over 1 and down 3. Connect that line. Again, it's going to be kind of free-handed toward the end. This is kind of our line here. I've made a mistake because, like we said, we want to use a dotted line. So I'll try to do that here. Here's a dotted line. Okay, and that's approximately what we have. And now we have to shade. So for the red one, we can very quickly see which way to shade if you plug in a point. So from this graph, this point right here, up here, is 10, 10. And if it is in the solution, at least if it does, if it satisfies the first inequality, the red one, we're going to shade in that direction. So we'll just try 10, 10. And so we have 10 is greater than or equal to negative 2 times 10 plus 8. And this is 10 is it greater than negative 20 plus 8? And it is, because this is negative 12. So that is correct. So we're going to shade in this direction for this red line. For the green one, we could do a similar thing. Let's use 0, 0. That's a pretty easy point to use. So for the green one, try 0, 0 to determine which way to shade. And we have 0 is less than 3 times 0 plus 5. And that is also correct. This does check out. So we're going to shade towards 0, 0. So that's this way. So we can see that the solution for both of these inequalities is where we see both the green and the red crosshatches. So now it's asking us, is the point 1, 8 in the solution set? You could go up here. 1 is here, and 8 is here. So I'm going to mark this in blue so it's a little easier to see. It's this point right here. Now, it's in the red one, we can see that for sure, but it's not quite on the green one because it's on the dotted line of the green inequality. That means it's not in that solution set. So we can basically say, confidently say that 1, 8 is not in the solution set. Not in the solution set. And that's mainly because it does not satisfy this inequality. We can actually even try that ourselves. We have y is less than 3x plus 5, and if we plug in 1, 8 into here, plug 1, 8, we'll get 8 is less than 3 times 1 plus 5, and we'll get 8 is less than 8, which is wrong. And so, the answer to here is that 1, 8 is not in the solution set. Right, question 22. The shaded boxes in the figures below represent a sequence. If figure 1 represents the first term and this pattern continues, how many shaded blocks will be in figure 35? So we could draw all of them all the way to figure 35, but that would probably be unreasonable. So let's see if we could find a pattern. In figure 1, there's 12 shaded boxes just by counting them. In figure 2, what we see, I'm going to highlight this red box right now. That in there, in set, is figure 1. That is basically figure 1. That has 12 inside. We tack on 4 more, one at each corner. So that's plus 4, and that gives us 16. We actually see the same pattern here in figure 3. What I'm boxing right now is figure 2, so that has 16 in it. But we're adding 4 more once again. So that gives us 20. That's plus 4. So we can very quickly find a pattern here. If 1 gives us 12, if 2 gives us 16, if 3 gives us 20, ... 35 gives us something. And that's just adding 4 each time. It's plus 4, plus 4. To go from the first figure to the 35th figure, if we just subtract it, that's adding 34 times, adding 4 34 times, right? So that can be represented by 34 times 4 plus the original 12 that we had. So we can convince ourselves that's saying from figure 1, add 4 34 times. And that, when you put it in your calculator, will work out to 148. So the previous question concluded our algebra section, and we're now going to move into the functions section. The table below shows the average yearly balance in a savings account where interest is compounded annually. No money is deposited or withdrawn after the initial amount is deposited. Which type of function best models the given data? We can eliminate 2 answers right off the bat, even if we don't really know what this is going to be. So we have all these numbers increasing. We can see it's always greater than the previous year. So that cannot be a negative rate of change, so not 1. And it cannot be a decay, because that's decreasing, so not 3. So we're left with 2 and 4. Now you have a couple options to go about doing this. Option 1, you will have a graphing calculator available to you at the exam. So if you use a graphing calculator, and you put these numbers in, you will see something that looks something like, not exactly, not to scale, something like this. That is pretty clearly not a linear function, so that'll lead us to choice number 4. The second way is more of a, after doing a bunch of these problems, you'll remember that when you're compounding interest, okay, the formula looks something like this. The balance of your account will equal the amount you put in, P, 1 plus the rate to the t power, where t is the time that it's been in the account for. This right here, that's raised to the t power, that is an exponential function. And in this case, it will be growing. So answer choice 4. So this next question is similar to the one we just did about exponential growth, and you'll see why. And it asks us a population that initially has 20 birds approximately doubles every 10 years, which represents this population growth. We're going to eliminate 2 answers very quickly. This is how I'm going to do it. So it says first initially 20 birds. this is initially 0 birds. That can't be right. Next, if it's doubling every 10 years, it should be growing. It should be going up, upward pointing, increasing. This here is a decreasing graph. So that cannot be the answer. So now we're just left with choice 3 and 4. Now, there's a couple ways to do this. I like to just try out the numbers that we have here. Here's the 20, right? And that looks like it's about 80. At 10 years, which would be out here, it's about 40. So we can actually try that. At 0, it's 20 birds. At 10 years, it should have doubled based on the question, so that should be 40. And at 20 years, it should have doubled again, and that goes to 80. This one definitely represents it much better. So we're going to say 3. You see here, this is not good. The 10 years is maybe about 30, 20 is 40, so this is not good. And just as a tip, when something's doubling every some amount of years, it should scream out to you exponential growth, and that's this type of graph that you see in choice number 3. This next question, we're being asked, Miriam and Jessica are growing bacteria in a laboratory. Miriam uses this growth function f of t is equal to n to the 2t power, while Jessica uses g of t equals n to the 4t power, where n represents an initial number of bacteria and t is a time in hours. If Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth over its time? So basically what we're trying to do is just set them equal to each other. These are the growth functions. So we can just say f of t should equal g of t, right? You want to achieve the same growth, the same number of bacteria growing. And so f of t we have is n to the 2t. I will call this n, actually I will call this nj because that's number of bacteria that Jessica will start with. And then in g, we're going to say, I'm sorry, that Miriam starts with, so this should be an m. Erase that real quick. Here's nm, initial number that Miriam starts with, and then g of t, nj, that's Jessica, to the 4t. Now, we are given some numbers. We're given that Miriam starts with 16. So that's 16 to the 2t equals nj to the 4t. Okay, we need to make these equal and figure out what this n is going to be. So why don't we use some exponential laws and rules that we know and simplify this real quick. This is 16 squared to the t power. In other words, 16 squared to the t power, like that. Okay, this is very similar. This is nj to the 4th power to the t. Okay, just from laws of exponents. So basically, to have the same amount of time, that's time t, okay, that's locked in, we're trying to figure out how to make these parts the same. So we can ignore the t for now and just say 16 squared has to equal nj to the 4th. Okay, now we can simply plug this in our calculator and figure out that 16 squared is 256, and you need nj to the 4th. If you do a 4th root of that, you will find that nj simply equals 4. So Jessica has to start with 4 bacteria, and that's answer choice 4. In this next question, Dylan invested $600 in a savings account at a 1.6 annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually, very important, compounded annually. Find to the nearest cent, do a little rounding, the balance in the account after 2 years. So you have to know the compounding formula here. I'll write it this way. B is for balance. The balance in the account should equal the amount you put in, the principal, so that's the 600 in this case, times 1 plus some rate, some interest rate, that's raised to the t power. That's how many years. So this is rate in years, or rate in a year. Okay, that's annual interest rate, so we're given that. And this is how many years. So these units have to match, right? So we simply have to plug in what is the balance after 2 years. So we say balance is equal to the 600 he initially deposited times 1 plus 1.6%, okay, to the t power, which is 2 years in our case. And you just have to plug this into your calculator. And you should get $619.35. All right, in this next problem, Tony records the height of a plant for her science lab, and her data are shown in the table below. Day 1, we're here, day 2, 3, 4, etc. It's growing at a constant daily rate. This should immediately scream linear function to us. Linear function. It's constant. It's growing by the same amount each day. Write an equation to represent h of n, the height of the plant on the nth day. So this is relatively simple. You can do it from observation. So in a unit change of a day, we notice that it goes up, or the height grows about 1.5 centimeters. From day 2 to 3, it grows yet another 1.5 centimeters. So this one can be done pretty easily from observation. That is the slope. That is basically the slope. One way to look at this is if this is x and this is y, change in y over change in x, that's rise over run. We could say 4.5 minus 3 over 2 minus 1. Right, so that's these data points here. We get 1.5 over 1. So that's a slope. So that's pretty simple then. That's just hn equals 1.5 n. But is that correct yet? Not quite. Because if you do that formula and you plug in 1, day 1, you will only get 1.5. You need it to be 3. So just from observation again, we can get that constant to be 1.5. So this will be our answer. Okay. If you're not as comfortable doing it from observation, you can always use point slope form. Right? Point slope form again is y minus y1 equals m times x minus x1. Okay? So we'll use that point. We're going to use the point 1, 3. It's that first data point, day 1 at a height of 3. So we have y minus 3, that's y1, it's this one here, equals the slope, which we have 1.5, which we calculated before, x minus 1. If you work this out, we get 1.5x minus 1.5 plus 3, and you will get the same answer of 1.5x plus 1.5 as your final answer. To be consistent, probably should call this h of n. Call this n. There we go. These are matching. Okay, in this next question, we're given a graph that shows the variation of the average temperature of Earth's surface from these 50 years. And it's asking us, during which years did the temperature variation change the most per unit time? So it doesn't specify increase or decrease, it just wants where was the most change per unit time. That should immediately scream out that you want the steepest line, whether it's going upward or downward. From observation, that's right over here. Okay, because that goes down 3 over 1. This over here is a slope that goes up 2 over 1. Okay, in this section, the slope is 0. In this section, we have up 1 over 1. Same over here, up 1 over 1, and this one's slope of 0. So this one here, we have, again, this is down 3 over 1. So that's the steepest section. Just from the observation, that is the steepest section. We can actually figure out what that slope is exactly. Slope equals delta y over delta x, rise over run. And we're going to take the 2 points, so we'll take 1965 as the first point there, minus, this is delta y, so we should be using the y-axis. So right here is negative 0.15. We're going to subtract the first point, which is 0. That's easy. We're going to divide it by their x values. So 1965 minus 1960. Okay, that gets us negative 0.15 over 5 years, which is negative 0.03 degrees Celsius, in our case, per year. This is the steepest part, and you can show in a similar way that the slope for all the other parts is not as steep as 0.03. this part will probably be 0.02, and then these are 0 on these flat sections. In this next problem, we're going to look at this diagram that shows x cubed plus 2x squared that's graphed. This here is this function, f of x. It says also graphed is g of x, write this in blue, which is the result, sorry, should be in blue. It's not changing colors. Here we go. G of x, which is the result of a translation of f of x. Now, translation, remember, is just moving it up and down or left and right. That's a translation. You don't change the shape of the graph itself. So you can tell it just from observation. You've moved this down to here, right? This is down to here. Everything just got moved down a certain amount. And it's asking us, what is the equation of g of x? And we can explain our reasoning. So you can explain that from observation, you see that it's simply shifted down. And when you shift something down, you simply change the y-intercept. So when you shift up or down, you change the y-intercept. Or basically, in our case, it's the constant that we have to change. So in f of x, we had x cubed plus 2x squared. And implicitly, not explicitly shown, but it's plus 0, right? There's that constant 0, and that's why it intersects the y-axis here. We're shifting it down 4. All we have to do then is just say g of x is equal to the exact same thing, because it's the same shape, but we want to subtract off 4. Now, we know this works because if we plug in 0 for x, so we say g of 0, plug in 0 for x, 0 plus 0 minus 4 gives us negative 4, and that is this point right here. So that's consistent, and that's how we know that the equation for g of x is simply the equation for f of x, but with an extra minus 4 added on at the end. All right, in this question, it asks us which chart could represent the function f of x equals negative 2x plus 6. All right, we could do a quick graph of this just to understand what this graph looks like. Here's approximately 6, negative 2 slope would look something like that. It's going to go downward. So just from observation, we already can eliminate some answers. It has to go downward. The y values are going down as the x values increase. This does not fit that pattern. It's 8, 10, 12, 14. It's going up. We need it to go down. That can't be the answer. In choice 1, 6, 10, 14, 18, by the same reasoning, cannot be the answer. In choice 2, it also goes up 4, 6, 8, 10. By the same reasoning, cannot be the answer. And just from that, we can be pretty certain that 4 is the answer. We can actually, before we select it, if we want to be a little more thorough, we could plug in each number into the function here. So we'll plug them in. So if we plug in 0, right, negative 2 times 0 plus 6 equals 6. That checks out with this answer. Then we go negative 2 times 2 plus 6 is negative 4 plus 6 is 2. That matches this answer. And so on, and you will find that these answers match as well. So our answer is choice 4.
So Sandy programmed a website's checkout process with an equation to calculate the amount customers will be charged when they download songs. The website offers a discount if one song was bought at the full price of $129 and each additional song is 99 cents. State an equation that represents the cost C when S songs are downloaded. So let's draw a table to visualize what this means. So when you download one song, this is S, you're charged $129. This is going to be C. And then when you download two songs, it's $129 plus the 99 cents, right? So let's convert this into an equation by, I think the easiest way to go about doing this is to put it into point slope form. So that would be y minus y1, which is 129. I'm gonna use this value. 129 equals, the slope would be 99 cents because that's how much it increases by each time, each extra song you buy. So that's 99 cents times x minus, and the x value here was 1. Sorry, that should be s. And this should be c. C and s. So we can either leave it in this form, or we can easily convert it to y equals mx plus b form. C equals, just putting the 129 over to the other side. Multiplying, distributing this out. S minus 0.99 plus 1.29. And this adds up to 0.3. Positive. And that would be our C. So the second part asks, Sandy figured she would be charged $52.77 for 52 songs. Is this the correct amount? Justify your answer. So we can either recheck her math, or we can simply plug these 52 songs into the equation we just derived. So we can do 0.99 times s, in this case it's 52, plus 0.3. So let me do that out quickly. 0.99 times 52 is 5148 plus 0.3. That gives us 5178. So it turns out Sandy was incorrect that she would be charged $52.77 for 52 songs, and when in fact the actual price would be $51.78, because when we plug it into the equation we derive from our point slope form, it's $51.78 rather than $52.77. So this question asks, the value v of t of a car depreciates according to the function v of t equals p times 0.85 to the t, where p is the purchase price, which is the initial price, and t is the time since the car was purchased. State the percent that the value of the car decreases by each year. So just by simply looking at the equation, we know that the car retains 85% of its value after every year, right? Of its current value that year. You just multiply it by 85%. So just by saying that, we know that the answer is 15%. But if in case you need any more convincing, we can write this out. We can draw this out to visualize what it is. So let's do t equals 0, t equals 1, and t equals 2. So at t equals 0, this term becomes 1, right? So then in 0 years since the car was purchased, which is the current time, it would be the purchase price, which is, let's just set it, in this case, 100. P equals 100 at the beginning. Let's set P equals 100, just for simplicity's sake. So then by the year after, we know that it's going to be 100 times 0.85 to the first power, which would be $85. And now this same pattern continues after each year, where you take 85% of this, of 85, which would be 85 times 0.85, which would be 72.25, and that continues. So we know that from here to here, it decreases by $15, right? And that's 15%. And in the same manner, it decreases by 15% as well, this, from the first year to the second year. So we know that the value of the car decreases by 15% by each year. And you can simply reason that by saying that the car retains, as I said before, 85% of its value of that year. You can further reason that because you plugged it into let's say you gave it a price, and you said that it, based on the table you created from plugging in those numbers, that the value of the car also decreases by 15% every year. So you can do it that way as well. So question 33 asks, in the functions f of x equals kx squared and g of x equals the absolute value of kx, k is a positive integer. If k is replaced by 1/2, which statement about these new functions is true? So we know that if we were to place a fractional value, less than 1, into this coefficient, that typically graphs get wider. So we can let's give an example of x squared. Let's start with x squared, then let's add the 1/2 coefficient to it. So x squared would look something like this, but then 1/2 x squared would look something. Let me change the color. Would look something more like that, right? It would get wider because the value of f of x wouldn't increase as fast as it would if the coefficient was 1. So in the same manner, the same thing would happen with absolute values as well. So if you were to do absolute values, let's say we're just doing absolute value of x, right? It would just look like that. I'll label it absolute value of x. And meanwhile, absolute value of 1/2 x would go like this. 1/2 x. And you can further convince yourself, because let's say it was just x, right? A regular line. So you know that that would look like that, right? And meanwhile, if you were to do 1/2 x, right, instead, you know that the slope is less than this original line, and it would not increase as fast. So you can use that to reason why the graph would become wider, and that would yield 1 as our answer here. And you make sure to read all the other answers as well. But by making the coefficient 1/2, this graph becomes wider. And conversely, if you were to increase k, for example, and say k becomes from 1 to 2, you know that instead of wider, the graph would become narrower, right? So this question asks, which ordered pair would not be a solution to y equals x cubed minus x? So which one doesn't work? So the first option here would be to just plug it in your calculator, I think. Option 1, calculator. So just create a graph on your calculator. If you have the Inspire, I think it's, you add a graph your function, go to the menu and search for, I think there's a table option, and then you can see which one of these 4 values isn't there. The second option is to simply just plug all these values in, and I'll do that for you here right now. Option 2, plug in. So let's start with option 1, answer choice 1, which would be -60 equals -4 cubed, which is -64, minus -4. And that's fine. This -64 minus -4, which turns into a plus, is indeed -60. So because that works, this is not one of the answers. Answer choice 2. You have -24 equals -3 cubed is -27, minus -3. This, of course, again turns into a plus, and that also works, so that's not an answer. 3, you have -6 equals -2 cubed is -8, minus -2. Again, this is positive. So you add it, and -8 plus 2 is indeed -6, so that's not an answer either. Answer choice 4. You have -2, and these are fairly simple to work out. So -2 equals -1 cubed, which is -1, minus -1. This one does not work, because -1 plus 1 is actually 0, which does not equal -2. And that is our answer. That is not a solution. So question 35 asks, which situation is not a linear function? And the first one, it's the first answer choice, it says, a gym charges a membership fee of $10 down and $10 per month. That looks like a linear function, right? Because you'd have that initial 10 value, right? Plus 10x, right? That would look somewhat like that. And then in the same manner, you have initial value here and a slope value here. So this would be like something like 3x plus 2.5. This one is just a standard rate of $12.50 per hour. So the money that employee earns is just 12.5x. But so all three of these are linear, right? They're all our y equals mx plus b form. But finally, on this last answer choice, you have a $12,000 car depreciates 15% each year. So that would mean that it only retains 85% of its value after first year, right? So if initially it's 12k, right? 12k times 0.85 is, so by at the first year, it would become 10.2k, then it would be 8.67k, and this isn't a linear relationship. The difference between this and this and this and this isn't constant. It's an exponential decrease. Therefore, 4 is our answer. So a car was purchased for $25,000. Research shows that the car has an average yearly depreciation rate of 18.5%. Create a function that will determine the value v of t of the car t years after purchase. So let's model this out really quickly on the side. I'll write out a table. T and v of t. We know that in year 0, the value was 25,000, which was the initial. And you have years 1 and years 2. So saying that the car has an average yearly depreciation rate of 18.5%, which is the amount it loses that year, right, is the same as saying the car retains 81.5%, right, which is derived by doing 100% minus 18.5%, gives you 81.5%. So to get the value of year 1, you can either multiply 25,000 by 0.815, or you can multiply 25,000 by how much it loses, right, times 0.185. But because this is the amount it loses, you're going to have to subtract this from 25,000. And these values are equal to each other. Same thing. But this first option just simplifies it so much more, right? So at the first year, we can do 25,000 times 0.815 to get $20,375. And then in year 2, you can do the same thing. Multiply this 20,375 value by 0.815 to get 16,605.625. So we know that the relationship between here and here and here is that you're multiplying it by this 81.5%, right? 0.815 times 0.815. So we know at the second year that you're multiplying this, at the first year, you're multiplying 25,000 by 815. In the second year, you're technically multiplying 25,000 by 0.815 and another 0.815, essentially being 0.815 squared, right? So you can see that relationship between those years. You're multiplying the original amount, we said was 25,000, by 0.815 to the power of how many years after purchase, which is how we get this relationship. Now, the second part of the question asks, determine to the nearest cent how much the car will depreciate from year 3 to year 4. This essentially is asking us what the difference is between year 3 and year 4. Now, because we already have the equation, we can simply plug in v of 3 equals 25,000 times 0.815 to the third, right? And then V4 equals 25,000 times 0.815 to the fourth. And then the difference of that, which is V4 minus V3, would be our answer, correct? So let's calculate that out. And it also asks us to round to the nearest cent, which is the 100th place, right? So in this case, after doing this, you get the value 2,503.71. So now let's switch gears to the new topic, statistics and probability, which will cover the last 4 problems, number 37 to 40. So given the following data set, which representations are correct for this data set? Here we have a dot plot, a box and whiskers, and we have a histogram. Now let's quickly write out on the side here what each frequency is for each one of these values. So you have 65, we have 70, we have 80, we have 85, 90, 95, and 100. There's 165, there's 1, 2, 3, 4 70s, there's 1, 2, 3 80s, there's 185, there's 290 values, there's 395 values, and there's 100 value. So let's see if the dot plot accurately reflects this. 165, 470s, that's correct, 380s correct, 185 correct, 290s correct, 395 is correct, and then 100, which is correct. So representation 1 is good. And I'm going to quickly skip over this and come back, the box and whiskers, and come back to it. Let's look at the histogram quickly. We have intervals on the bottom. So this interval is 61 to 71. So the first interval encompasses these 2 values, right? We add them up, and that gives us 5. And this is 5, that's correct. 71 to 81, that's just this one. 3, that's correct. Interval 81 to 91, which covers these values. Added up, you get 3, that's correct. And then finally, we have 91 to 101, which covers these values, and that adds up to 4, which is correct. So we know that the histogram is also right. So finally, let's verify the box and whiskers. We know that 65 is the lowest value. We know that 100 is the highest value. Now it's time to find the median, third quartile, first quartile. So let's quickly find the median here. So let's just cross out values on either side. So it looks like our median is 80, and that's correct. This is correct. So let's quickly check our quartiles, right? So I'm going to go in green on them for them. Boom, 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 boom. So that's our first quartile. And then same thing here. And this is our third quartile. 95 is indeed our third quartile, and then our first quartile is indeed 70. So this one actually works too. So all 3 of them work. And the answer that has this is answer 4. So here we have the heights in inches of 12 students. And the question asks, which statement best describes the spread of these data? So one option would be to put this in your calculator and see in a list and spreadsheets page on an NSPAR calculator and plot it out as a dot plot on a data and statistics page if you want. But here I'm just going to quickly order these this data in ascending order. 59, 60, we have two of them, right? 60, 60. You have two 61s. You have 162, 63, 64, 65. You have a 67, 72, and 79. All right, so the first answer choice says the set of data is evenly spread. Now, does this really look evenly spread? You have a bunch of values over here that are very, very close together, but then these ones are like further apart. You have a 72, then you skip 7, 79. In between these, you have a 5 difference. So I don't think the value is evenly spread at all. And the second one is the median of the data is 59.5. Here we have a even number of values, right? So we split the data right down the middle. Just do this. So the middle is right here. This would be the median, which is in the middle of 62 and 63, which is 62.5. And that is definitely not 59.5. So the third answer choice says the set of data is skewed because 59 is the only value below 60. Well, 59 is the only value below 60 in this data set. The data set is not skewed because of it, right? You just have a high concentration on this side. Now, finally, for answer choice 4, it says 79 is an outlier, which would affect the standard deviation of these data. So what is an outlier, you must ask? That's defined as 1.5 times the interquartile range. And then you either add this to the third quartile, or you subtract it from the first quartile. In this case, we're only concerned with 79, so it's on the upper side. So we're just concerned with adding 1.5 times the interquartile range to the third quarter. So let's quickly find where the first and third quarters are. You know, the third quarter is in between 65 and 67, which is 66. We can do the same here. We know that it's in between 60 and 61, which gives us 60.5, right? And so the interquartile range is just the difference between the third and the first quarter. So IQR equals 66 minus 60.5. And that gives us 5.5, right? So if we were to multiply 5.5 by 1.5, we get 8.25. 1.5 times 5.5 equals 8.25. So we take this value and then we just we add it to the third quarter to see if 79 is within that. So 8.25 plus the third quarter is 66. 66 plus 8.25 is 74.25. So we know that using this rule that 79 is way higher than 74.25. So it is indeed an outlier. So that is true. And that it does affect the standard deviation of the data. So therefore the answer here is 4. So question 39 is heavily reliant on the calculator and in calculating the linear regression for this data. So on the TI Inspire, you can just add a list in spreadsheets and do it there. After you input your data, you can go to Menu, go to Statistics, go to stat calculations and go to linear regression mx plus b form. And doing so, after inputting all the data, you get a m value of 7.79220, and you get a b value of 34.2727. So of course we have to round this to the nearest hundredth. It tells us to. This rounded 7.79, and then for this one you get 34.27. So we have our y equals mx plus b form. Now this could be, in this case, it's the independent variable is x and the dependent variable is y, so this is fine. But just pay attention to these variable names just in case you have to change it. But this is fine, so we have y equals 7.79 x plus 34.27. That solves the first part. For the second part, it asks us to state the correlation coefficient. Now the correlation coefficient is the r value, right? So it's 0, r equals 0.98157, but we have to round that, so r equals 0.98, and that's our answer there. Finally, it asks explain what the correlation coefficient suggests in the context of the problem. Now, because 0.98 is so close to 1, we can say that it is a good fit, right? Good fit. And that it is a strong fit. And you have a direct correlation between hours spent studying to test scores. So in this final question, we have the dot plot, which shows the number of pets owned by students in the class. And the question is asking us which statement is not true. Not true. So if it's correct, we cross it out. So let's quickly, because we have median here and interquartile range here, and we also have outliers here, let's just find those quickly. So we have the median. Just keep crossing out values. So then we know that the median is right here, which gives us a value of 3, which is correct. So we can cross that out. Now let's go for interquartile range. I'll find the third quarter first. And we know that the third quarter is in between these two values, which are just a 4. We do the same thing here. Let's cross out 2 from this side, cross out 2 from that side, cross out another 2, cross out another 2, and then we have the first quarter in between these two values, which is just a 2. So interquartile range is the third quarter, 4, minus first quarter, 2, equals 2, which is correct. Cross that out. Now outliers, as I mentioned before, is 1.5 times the interquartile range, and you add that to the third quarter or subtract that from the first quarter. So we know that the interquartile range is 2, so 2 times 1.5 is 3. And if we add that to 4, 3 plus 4, this is the third quartile, you get 7. Everything looks like it's within that. And then we can subtract that from 2 as well. 2 minus 3 equals -1. So we know that all the data values lie in between 7 and 1. So the data does not contain outliers, which is correct. And finally, let's just verify that the mean is indeed 3. We have 2 zeros, and we have 2 ones. Oops, let me make sure it's consistent here. For 1, we have 2 of them. For 2, we have 5 of them, it looks like. For 3, we also have 5 of them. For 4, we have 3 of them. For 5, we have 2 of them. And we have 1 singular 6. And you divide that by the total number of students, which is 12. In this case, you get 55 over 12, which equals 4.583, which is definitely not 3. So 3 is our answer. So this concludes our Algebra 1 review, and we would like to thank you guys for listening, and we wish you the best of luck on your exam.